Hello, this video will demonstrate how to find the horizontal asymptotes of a function. Again, we've seen how to find horizontal asymptotes of rational functions by looking at the degree of the numerator and the degree of the denominator. But what happens if we have functions, other types of functions, okay? All we're going to do, we're going to look at the limits of the function as x approaches infinity, positive infinity, and negative infinity. So let's look at an example. All right, I would like to find the horizontal asymptotes of this function. Okay, so what we said was we want to find the limit as x approaches positive infinity of this. And remember, we could always just choose some really huge number of x, plug it in, and see what happens. Or we can be a little more algebraic in our approach to finding the horizontal asymptotes. All right, no problem. Okay, again, you really need to know your algebra in this case. So again, if I plug in a number, okay, let's plug in, I don't know, 1 with 8 zeros, right? Again, 1, 2, 3, 4, 5, 6, 7, 8. Divide by, in brackets, 4 plus 1, 1, 2, 3, 4, 5, 6, 7, 8. Square it, close parentheses, take the square root of that, and then that's, oh, hold on a minute. I think I might have put too many ones in there. Okay, 1, 2, 3, 4, 5, 6, 7, 8. Divide by, parentheses, 4 plus 1, 2, 3, 4, 5, 6, 7, 8. Square. Close parentheses. Take the square root of that. We get 1. So you can do that, right? That's not a problem. But we want to be very algebraic about this. Okay? We saw in class a few times, and again, it's also in the notes, if I look at the denominator, and I factor out an x squared. Why do I do this? Because I know what the limit of this is as we approach infinity. It's 0. Okay? Well, what's the square root of x squared? X. No problem. All right. The x's cancel to 1, and so I'm looking at the limit as I approach infinity of 1 over the square root of x squared plus 1. Okay, as I approach infinity, the limit of 1 is 1. As x approaches infinity, the limit of 4 over x squared is 0. All right, so I have the square root of 1, which is 1. Okay, so that means I have a horizontal asymptote. One of my horizontal asymptotes is y equals 1. Okay, and let's see, whoa, that's a little crazy. Let's, well, let's just do this. All right, let me try another color here. Let's do purple. There we go. Okay. So what do we do here? We're going to do the same thing, but we want to be really careful at this point, because when I have this, right? I have take an x squared out. We want to be really careful about this because we're trying to find out what happens as x approaches negative infinity, which means x is a negative number. And you need to remember, in this particular case, right, so if I have, right, sorry about that. If I have the square root of negative 7 squared, this is not equal to negative 7, this is equal to 7, or the absolute value of negative 7, okay? So when I take the when I take the square root of x squared, I need to remember that this is the absolute value of x, because x is negative because I'm going to negative infinity, okay? And these are the little things that you have to keep in mind when you're doing this crazy stuff. Okay? All right. So another way to think about that, right? This is positive and this is negative, correct? Because we're going to negative infinity. All right? So be very thoughtful about this. This is negative. So I want you to think about this. Negative divided by positive is negative 1, correct? And now where I'm here. So this is going to be, the limit of this is going to be negative 1. So I have another horizontal asymptote at, all right, negative y equals negative 1. All right? Again, there's a lot of interesting algebra here. Not very difficult, just you have to be thoughtful about just something as simple as a square root. All right? Let's look at the graph to see if it matches. And sure enough, we can see that there's a horizontal asymptote at y equals 1 and at y equals negative 1. And you may be saying, oh, come on, let me just put in a huge number here, huge positive number, a huge negative number, and I'll get these answers. You're absolutely correct. You will. But you should know how to do this algebraically as well. All right, let's look at another one. Okay, quite similar, all right, but a little, just a little different because we have this negative here. Okay, so again, what we're going to do is look at the limit as we approach positive infinity and as we approach negative infinity. Okay, so just like the example we just saw before, right, we're going to factor out an x or a square root of x or something like this. And we notice in the denominator now, it's the square root of negative 1, which obviously is an imaginary number. So how do we interpret this? Well, let's look at the graph and see what happens. Okay, while there are vertical asymptotes, no problem, there are no horizontal asymptotes, right? There's no ceiling or floor. Again, don't be confused. There are vertical asymptotes, but no horizontal asymptotes. And so again, we're just say no horizontal asymptotes. Okay, so you have to know how to interpret the results of your algebraic solution. Okay, one last example. All right, we're going to look at the limit of 4 times the inverse tan of x minus 1. We're going to look at that as we approach infinity. Okay? All right, no problem. We can use our rules here and separate all of this. This is actually a really nice one. All right, infinity of 1. Well, I know that the limit of 4 as x approaches infinity is 4. I know that the limit of 1 as x approaches infinity is 1. But what is this? And this is important that you remember these graphs. Here's the inverse tan of x. And as x approaches infinity, the limit is pi over 2. Okay, so this is pi over 2. So the limit, 4 times pi over 2 is 2 pi. our limit as we approach positive infinity is 2 pi minus 1. So we do have one horizontal asymptote, and that's 2 pi minus 1. Okay? We can see as we approach negative infinity, most of this stays the same except for the limit of the inverse tan. As we approach negative infinity, if you remember this graph, as x goes to negative infinity, the function goes to negative pi over 2. All right, 4 times negative pi over 2 is negative 2 pi minus 1. So here are our all right, horizontal asymptotes. Again, let's look at the graph to see if this matches. By the way, just so you can see what this is going to look like, right? 2 pi, right, is like 6.28 minus 1, so this is about 5.28, something like this. And this is negative 6.28 minus 1, so this is going to be something like y equals negative 7.28. So when we look at the graph, think about this. Okay, and if we look at our graph, we can see that we have a horizontal asymptote here of, what did we say, about 5 point, what did we say? About 5.28, okay? And that's about right. Okay, again, if we need to go out a little more so we can see that. Right, there's about 5.25, you can see that. Again, horizontal asymptote here as well, negative 7.28. All right, so again, as you're practicing, it is important to check a graph, see that the graph actually matches what you are doing algebraically. Okay? Again, I hope that helps. Remember, in the grand scheme of things, you can always just plug in a really large number in here and see what happens. But you're not going to get 2 pi minus 1. You might get 5.28 something, but you probably won't realize that it's 2 pi minus 1. This is the exact horizontal asymptote. So it's important to understand algebraically what we're doing here. All right? Okay, well, I hope that helps. Thanks for watching.